Yeah, hello again. As you can see, I'm standing here in front of our new Industry 4.0 system. I was told you know the general setup of the system already quite well, so I don't need to go into the details of the production line itself. We still have the work pieces built up in our factory. We have similar working stations. What has quite changed a bit are the transport systems. I will tell you a little bit what's new in comparison to your LM9606 systems. You will notice already we have an entirely new front platform. So we changed this conveyor belt to be an entire cyber-physical system. So what is a cyber-physical system? A cyber-physical system has to have three different components. Every system has to have it. The first component is the PLC. In our case, we use a Simatic S7-1200 from Siemens. It's an industrial PLC commonly used in a lot of factories. So this computational device is the first part of the cyber-physical system. Secondly, we have to have sensors and actuators. So in our conveyor belt system, we have the end limit sensors on the left and on the right side, as you know them already from your systems. We have an encoding wheel with the light barrier in our conveyor belts for positioning. And completely new, we have an RFID sensor head in every of our conveyor belt. This RFID head is connected via IO-Link to an IO-Link master, which is connected to our PLC. Every IO-Link master has 4 ports for intelligent sensors. Every belt has an RFID, and every station has another IO-Link sensor we use. It's the ultrasonic sensor for measurement of the filling level of the magazine. So every device has 2 empty ports for more sensors you can place there as you wish. You can be quite creative with these ones. So that's the sensors of our belt. The actuator is still the direct current motor, as you know from your systems already. The third thing, besides the PLC and the sensors and actuators, the third thing every cyber-physical system has to have is a user or a communication interface to program the PLC and to communicate with other PLCs. In our system, we use the LAN ports with Ethernet wires. We have 2 of them available here. They are internally connected via a switch and done here into the PLC. So two ports connected via a switch. So that makes up the main part of our conveyor belt system. As you can see here, you have another inputs for sensors. There's still one available spot here. You have M12 connectors. There are 2 available for more sensors. And you have 2 buttons for example, for initializing a step sequence or whatever you feel like if you program them yourself. So yeah, that's entirely new in comparison to your system. How did we implement the RFID in our Industry 4.0 factory? As I said, every conveyor belt has one RFID head now. In the old systems or in the system you have, there are only 2 ones. It's the IMS1 for reading, for writing a product number to the ship, to the ship on the carrier, as you can see here, or RFID transponder ship. And you then read the product number in the IMS3A, and regarding to that product number, it's going to be manufactured. In this factory, it's working a little bit differently. So in Industry 4.0, you don't want the instruction manual on the chip anymore. Where we have it, if you order a workpiece in the ERP system, in the enterprise resource planning system, I will come to it later, you order it online, and all the data is saved in a database and stays there in a cloud. And this cloud is connected via the MES, the Manufacturing Execution System, and the RFID to our system. So the MES connects the instruction, the building instruction, via an identification number to the carrier. So wherever this carrier is, once it reaches an RFID point, the MES system will know this is this carrier, and this or this instruction depends or belongs to it. So in this way, everything, all the instructions are in the cloud and just ordered to the carrier. Yeah, that's how it works then. We will start here, as in your factory, start with the IMS3, or IMS3B, putting the lower part of the workpiece on, and go in a circle around here for the upper parts and the bolts. And then we have here a robot, as you can see. We are here using a UR3, which is a cobot. What's a cobot? A cobot means you won't need a security area here anymore. You don't need glass protection or light barriers for protection. This cobot just reacts on the people. It has sensors. If it works and I touch it too strong, it will just interrupt and stop itself. I can demonstrate it later. This robot grabs the workpiece, puts it here on the measurement or checking station, and the testing station, it tests whether the produced workpiece is the ordered workpiece, and if that's the case, the robot takes the workpiece and it's taken off the factory in this IMS7 station. That's quite similar to what you already know. Right. What else do we have? What communication protocols are we using? We have here mainly three big protocols. The first one is Profinet. Profinet is used for the communication between the PLCs. We have all the slave PLCs on every conveyor belt one, and we have a big master PLC, the S7 1500, in our frame over there, and they are communicating via Profinet. Via Profinet, there is exchange the RFID data. If there's RFID available, what data has been sent. It's sent the filling level of the magazines. It's sent whether or in which state every conveyor belt is at the moment. These are the data which are sent via Profinet to the master PLC. Also, it's sent whether CoAP is available or is active. What's CoAP? CoAP is another communication protocol. We use the Ethernet wires for, but not to communicate between the PLCs, but rather to communicate between the PLC and our ERP system. So the ERP has the database of the ordered product and gives requests and responses to our PLCs. The PLCs then provide also to the ERP system the filling level of our magazines and the state the conveyor belts are in. So that much for the communication between the PLCs, the ERP system, and everything. The third communication protocol we have here also is we built in a router, a Fritzbox. So this system is it can do Wi-Fi. We can connect via a web server to the system. We can use any smartphone, tablet, or laptop to connect into our master PLC and use a normal browser to steer or control and to read the sensors and actuators in our system. Yeah, So that much to our devices here. Then we can have a look what we have here. As I mentioned already, here's our master PLC. Here's our touchscreen, our human-machine interface, as you know it already. It's a little bit worked over as well. You can see a little picture or image of our factory, and you can see here where the carriers are right now. And it's a little bit gray, and you can see which conveyor belts are active. You have here 3 buttons. I want to activate CoApp, to activate the communication to the ERP system. Another one, you have robot. You can enable or disable the robot, whatever you feel like. If you don't want to use the testing stations, just disable it. And another button for smart grid. The smart grid button can be used for several things. For example, if you have a windmill or a solar power plant device from us, from the energy engineering department, you can produce your own economical power for the devices, for the system. And once this economical power reaches a certain level, this system will start by itself by using the smart grid. Another application could be, for example, we had customers who used Amazon Alexa for voice control of the system. You can also connect that to the smart grid interface. So that much to the HMI. Now I will introduce you our ERP system. That's probably the most important part of our new factory, and that's the really big difference between Industry 3.0 and 4.0. So I will share my monitor with you so you can see it. So it's good, I guess you can see it. So our ERP system runs on a virtual machine in background. So it's independent of the actual hardware you use. You can just use the virtual machine, load it on your computer, and from there you start it in an internal cloud, in an edge cloud. So this cloud is available in an intranet, but not available in the normal internet, so it's safe. You can use it within your own network. So once you open the ERP system, you see a couple of tabs over here. I'll start here. That's just a list of orders which has been sent and accomplished already. Every order gets an ID. You can see some data, when it's been built, how long did it take, how long did the production have to wait until it started. So just a common or general list. Then you can, I'm in there, we get to that later. In our factory, then under stock, you can see how many workpieces are available in our magazines. Yeah, these are updated now fully automatically via our ultrasonic sensors over I/O link. Then an important tool is our SCADA system, supervisory control and data acquisition system. This helps you to watch your sensors, to see if there's an error, is there any fault in your system, how you can maintain your system. It gives you a warning if something happens. Also, you see here on that every station is connected via CoApp with the ERP system. The next field tab we have is the MES system. That's used if you want to make major changes about your system. You have, if you, for example, want to build in a new working station, you have to tell the manufacturing execution system what you changed, so the computer can calculate with it and gives new instructions. So whatever you change on your system, just go to your MES and make the changes here, like putting in new connections. For example, here, the order of your working stations you can change here and so on. Also, you can see your orders and monitors. You can see them, you can reset them, you can delete them. That's all done here in the MES system. The next one is the ERP system itself. We use a didactically built up system. So you wonder why not Microsoft or why not SAP? I can tell you, if you use these huge systems, your students might need months to just understand how the user interfaces work, but they will never understand how the ERP in connection with the MES and all the hardware connects and really fully understand it. We built up our own ERP system, which has everything the ERP of, for example, SAP includes as well. For example, you can see here all the total orders which have been done, how many sales. You can get customer informations, where to send the products. You can make coupons, you can make marketing instructions. For example, here you can make vouchers. Everything in a real web shop or in a real ERP you can do here. Analytics as well. Right. So the next and maybe most important one is our web shop. As I mentioned before, this web shop is in the cloud. You can get to it via any browser you connect to our Wi-Fi, and for example your tablet, and we use an open card system. And I will get to it here. A little demonstration. You can choose between two products, with bold and without bold. And if you use with bold, for example, you can choose which color you want to order. I will do it here. Once you put it in your, wait, we can also change the language, right? So I ordered a bold product, I add it to my cart. I can order a different one as well. I don't know what I just ordered, but then I go to my cart, continue. So here you can put in consumer information. This information will be saved in our ERP system and can be used for later analytics, or you just continue as guest, as in a normal web shop. So what you see happening here now is that the ERP system sent the order to our factory. The MES system takes charge of the instruction, and the carrier drives around the system here now and builds in the work pieces. Now our robot was enabled. I think I misclicked the second order, but that doesn't matter. Then it's dropped here. I will show you the cobot ability now. Once the cobot moves, I can just touch it here and it will just stop. So for security, you can put in any force at which this robot is supposed to stop. Then you can activate it again and it will keep going. So that's totally safe. You don't need any security fences anymore. Yeah, so that much to the factory itself. Now, of course, your students can't start with a complex system as this. You can't just put your students in front of the system and say, okay, just program it. That won't work. So you are familiar with our system already. You can just take it off. You can just take everything here off. You can take these stations off, and you can start with a single conveyor belt. I have one here. I don't want to take apart right. So you can just start with this conveyor belt. And what you can do with it is, since it's an entire CPS, as I mentioned at the beginning, it has a PLC, every student can program with just this belt, just use a laptop or a computer and program it. So there's a lot of things you can do with this already. For example, you can start, first thing you have to do the hardware configuration in TIA Portal, put in the right PLC, set the in and outputs and everything. And then you can start with turning right, turn the belt left, just learn the basics for the students. After that's done, you can include the sensors. Just start at the left end limit, drive the carrier to the right, have it stop there. Just the really basics. You can also use the positioning sensor, the encoder wheel, to count, use a counter function, use timing functions. There are a lot of possibilities just with this belt. If they have the basics, if the students have the basics, you can do a PWM signal, pulse width modulation also for the speed of the conveyor belts. Just drive it slow, drive it fast, set the outputs for it on the PLC, drive a ramp, whatever you feel like. So there are a lot of things to do just with the basic conveyor belt. Once they learned the basics, you are free to do whatever you want. There are many possibilities you can continue now. If they finished, if they understood the belt itself, you could, for example, place a working station on it and have the students build up a step sequence and a state machine for work with the station. Just drive the carrier in the middle, have it work, go to the right end limit sensor, just as it's done in our factory here. So they know already how the single stations work. Or you say you want to stick with the conveyor belt and you want to show them the IO-Link sensors. We have our own courses just for IO-Link, for the intelligence sensors that would look like this. We have here the ultrasonic sensor, and we have the RFID heads. There are a lot of projects you can do with intelligence sensors, like writing on our RFID transponder, reading it, getting the position of the carrier by the ultrasonic sensor. You can have diagnostical functions, for example, reading out of the ultrasonic sensor how many hours it has been working already, and so on. Cyclic functions, acyclic functions, it's all explained in our courses. Or you say you want to help the students understand the full system, you just connect the ERP system to one single conveyor belt. So you don't start with the entire factory, just connect the ERP system to one belt and have them order something. They will know which functions they will need in TIA Portal to stable the communication. You can use the ERP with just the belt, or you can use it with a belt and a working station. You feel free for whatever you want to do. Another possibility would be using two conveyor belts and establish a communication between them. Use one of them as a master device for Profinet and use one of them as a slave device and have them control each other. So there are endless possibilities, and just be creative. Yeah, that's that about the system itself. We keep working on further improvements and other devices we can attach to our ERP system. One such a device I want to demonstrate here as well. That's our intelligent manual station. So as you saw, our factory builds up the colors black and white for our upper and lower parts, and there are also two colors or two materials for our bolts, as you know from your factory. But what happens if you want to have a larger variety, or even if you have your own products you want to include in the ERP system, which you can do, then you might need this working station, which you can configure in every possible workpieces you put in the correct shelves, and then this workstation will help you to build it together. I will demonstrate it to you how it connects with our ERP system. So here, come back here once again, I can order the color or a workpiece with the color red, which isn't available in our factory. I add it to my cart. I place the order, and the ERP system will now that the factory can't produce it, so it will give the order to our manual working station. As you can see, here are LEDs which show me what workpiece I have to grab, and here is a LiDAR system which scans the surroundings and looks where my hands are grabbing. So if I grab this device, the beamer up here shows me how to place it, and the LiDAR system will know that I grabbed it. Then it shows me the next device I have to take. I can grab it here and continue with my bolt. So once it's really it's manufactured done, I have to push the manual button, right, and it's done. So that's all connected with our ERP system, and you can use your own products. We also have other devices. You could connect a 3D printer, for example, in your ERP system. You can enhance your web shop with your own products and have them printed in a 3D printer over using your ERP system. One more thing I want to show you is our augmented reality application for tablets and smartphones. I have to disable the co-app connection. That's a rather new thing we developed. What does it do? We have our tablet or smartphone, and it's connected to our factory over the Wi-Fi router. So the application can grab all the variables, the input variables, and certain specified marker variables directly from the PLCs. So that means you can visualize your sensors and actuators, the state of the sensors in an augmented reality application right on your tablet. Let's see. So yeah, we have here, good. We have our application, and we are using a marker on, can you show it? Yeah, we are using here a marker for our factory. By using this marker, our application knows where in the factory it's located, and it takes all sensor and motor data relative to the marker. You will see and understand it in a moment. So you configure your belts in the app. You can also configure entire factories here, and then you can grab then you can see all your variables here. For example, it can have this belt running by just pushing here the buttons. And I can use it as augmented reality function. So I can scan my surroundings. Hmm?
Just keep it stable 1 second.
Yeah.
Sensors.
Yeah. I have to scan my surrounding ones, and then I have to scan my marker. So it will find the marker, and relative to that, it will show the programmed sensors. For this application, I just programmed for this one conveyor belt, the sensors, the end limit sensors, and the motor here. And if I push it right or left, you can see it just shows. I can also, here, if I place the carrier underneath, it will show that the output of the sensor is active. So that's a big help for maintenance. And it also works for just one single belt. You can use it. You can program the workstations on top as well, or you program the entire factory inside. Yeah. Yeah, that's a cool new thing for augmented reality. There are other devices for extending our industrial factory. For example, AVG, AGV, an autonomous guided vehicle. We have one here. It has also a cobot on top, and it has stereo cameras and LiDAR systems, and you can use it for communication with your PLC. And for example, it can be used to bring a workpiece from your manual station to the factory or whatever you want to program it. And there are really a lot of other devices we have. For example, we have an AR printer soon available, which prints a QR code on our workpiece, and then you can scan this QR code with your smartphone and have a 3D view of your workpiece. These kind of things are available. Yeah, I think that should have given you a good overview over our system. If you have any questions, feel free to ask. Thank you.